Hey, good Monday, good Saturday morning. It's about 9:45 in the morning. I'm recording this. This is lesson 3.1. We're going to talk about looping over strings with for loops. We're going to find that all of these problems that we're writing with for loops can be solved with while loops. It's just that the code ends up being a lot simpler and easier for us to wrap our heads around when we use a for loop as opposed to a while loop. Let's go ahead and dive right into doing string stuff with. A common loop usage is with a string, you might want to look at every letter in a string, starting with the first letter, working your way to the back. You can do something where you count all the letters that are vowels, or you can, swap letters around, reverse the string, and so forth. We want to use a for loop to accomplish this task because the for loop is set up very nicely to go over all the indexes of each letter of the string. So just remember, strings are going to be 0 indexed, so that means that we start at 0 as the first letter, 1 is the second letter, and 2 would be the third, and so forth. And then the last letter is going to be at the position, what would it be? It'd be at length minus 1 is the last letter. Okay? Is the last. And so if you were to write the following loop, you're going to end up touching every single character in the string so long as you're accessing the characters at the given substrings. So let's go ahead and try to break down this loop and see if we would in fact get through all of the letters, and we can do this with a particular example. So first and foremost, I want to say that we do start off at 0 every time because that's going to be the first letter in the string, and we go strictly less than the length of the string. So because the last letter is 1 fewer than the number of characters, we want our for loop to stop when we get to the letter that's 1 less than the length. Okay, so this would be the last index we'd want to process. And then inside, and we go up by ones each time, so up by ones. And then this is saying while it's less than, we do something with the substring that's at I plus 1. Okay, so we could take a walk through this with a particular example and see how this actually behaves as we intend it to. So for example, if our string is equal to, let's do something small, let's just do cat, then we're going to go ahead and make a list of what each of these things are. So first and foremost, the length is always the same length. So string length is str.length 3. And so we can effectively replace this here with 3. So let's go ahead and do that. So here's our I. I'm going to also denote what is the string substring at I plus 1 over here. So this is the substr. And then we say, okay, so we have I, and we are comparing it to I. And so in the first case, I is 0. And so if we grab the substring 0, 1, so substring 0, 1, 0, 1, 2, substring 0, 1 is C. Oh, I forgot to mention, I is less than 3, so 0 is less than 3. So we grab C, and then we increment I, and I goes up to 1. And we check, is 1 less than 3? True. And then we're going to grab the substring that's at 1, 2. So 1, 2 is going to be A. And then we increment I up to 2. Is I less than 3? True. And we go ahead and get the substring that's at 2, 3. So 2, 3 is going to be T. And so that's going to be T. and then we increment I up to 3, and we now check is 3 less than 3, and that's false, and so we quit the loop. And so at that point, we'll have looked at the C, we'll have looked at the A, and we'll have looked at the T in the whole string. So this is the main kind of loop that's going to look at every single letter inside a string. Okay? Start at 0, up to the length of the string, up by 1s. Do something with that substring at I plus 1. Alright, let's look at an example of using this in an actual problem. So our problem is going to be we want to reverse a string. So we want to take a string that reads, say, let's do kind of an example, reverse a string. You want to go from like funny, Y, oops, I want to reverse it. So my first letter is Y, and then N, N, U, F. Okay? So we're going, you know, we're looping over every letter in this string, except we're going to kind of do this in a reverse order. So there's a couple of different approaches you can do to solve this kind of problem. So one approach is to say, well, how many letters, you know, here are my indexes, 0, 1, 2, 3, 4, right? If we do our typical for loop where we go from 0 to 5, then how could I compute the index? I want to get, so here's my I, and I want the character index. So what's the index of the character I want? So here's 0, 1, 2, 3, and 4. And I want 4 first, right? Because I want this Y, so I want 4. And then I want 3. And then I want 2. And then I want 1. And then I want 0. And so this is going to be the Y, the N, the U, and then the F, right? 4, 3, 2, 1, 0. So if we can make a for loop that computes what this number is over here from I, so if we find a pattern, so I is going from 0 to 4, we can find a pattern for what these numbers are on the right, then we can actually figure out what that letter is, okay? So what is our pattern? Pattern should be kind of clear to see as we go down up by 1 each time over here. We're going up by 1, and over here we're going down by 1. But we're starting at 4. So we're starting at the index of the last character, and we're decreasing by 1 each time. And that makes sense, right? We're starting at Y, and then we're doing N and N. We're decreasing, we're going backwards over the string. So each of these numbers over here, 4, 3, 2, 1, 0, can be computed from 0, 1, 2, 3, and 4 by looking at the index of the last letter. So this over here is just 4 minus I. Okay? So, you know, if I is 1, 4 minus I is going to get you 3. If I is 2, 4 minus I is going to get you 2. 4 minus 3 is going to get you 1. 4 minus 4 is going to get you 0. So this is giving us the index over here that we want from the value of I. Okay, so how is this going to look like in code? So the first thing is we're going to build a empty string. So we're going to have an empty string that's going to be the answer, the enough answer over here. And we're going to loop like we had the last time. We're going to go over each character in funny, starting at 0, going up to string.length. And so these are going to be these values of I over here on the left. So I will start at 0 and go up to 4 if our string was funny. And now we have to compute the index of the last character, the character we're going to. So the last position is string.length minus 1. Remember, that's our constant 4. It's going to be 1 less than the length, because if our string is funny, its length is 5. That's the length of funny. It's 5 characters. So string.length minus 1 minus I. So that's our formula right here. So it's the length of the characters minus 1, which is the position of the last character, minus I. And then we just glue that. So we glue that letter, which is str.substring, last position plus 1. We glue that to reversed, and we loop over all the characters, and at the end of the day, reversed will have the string reversed. So let's go ahead and give this a test in IntelliJ. So you can open up an IntelliJ and project, and I'll do this with you. So here's reversed. There's my empty string that I'm going to hold the reversed answer in. We'll loop int I equals 0, I less than str.length, I plus plus. And then we compute that last position, str.length minus 1 minus I. So again, str.length minus 1 is going to be the last character's position. Take away I because we're going backwards from the last character to the front. And then we glue reversed plus equals str.substring and its last pos last. Okay, so this is always going to get you the character at this index because you have one character, you know, you're going from this one and one more not inclusive, so you always get the last character from this. So let's go ahead and test it out. Hamlet should give us Telma. There it is. Hamlet backwards. Okay, so that's one way of doing this. And I'm going to show you another way that may be easier to think about or might make more sense for you. And just know that both ways are perfectly valid. The other method, I would say, it makes a little bit more sense to me, but might be not as obvious if you haven't done for loops before. Okay, so we're going to do another method. I would say it's simpler. It's less code, really. It's just less code. And for some people that means simpler. Okay, so now we do the same setup. We create a string that's an empty string that's going to hold our answer. Then we, instead of having our for loop go from 0 to string.length, we have our I values be the indexes that we want. So remember, our indexes for funny were 4, 3, and 0. So we just need a for loop that goes over those numbers. So what are we starting at? We're starting at the last character, the last character's index. So this is the index of the last character, which would be 4 for funny. And we are looping as long as it's greater than or equal to 0. So we are going down, right? We are starting at 4 and going down. And as long as the I is greater than or equal to 0, we want to keep going. And then we decrease by 1 each time. So by 1. Whoops, cat's getting all up in my business. So that is exactly you know, what for loops are meant for. They're allowing us to kind of find a variable and find a pattern and employ that pattern directly in that variable or in that for loop header. Okay, so and then we would just grab that ith letter and glue it onto reversed. So we're going to go ahead and implement this version now in IntelliJ, and it should behave exactly the same. Okay. So here is the last one. We can call this reverse 1. Let's make another one. Reversed equals empty string for int I equals string.length minus 1. I greater than or equal to 0. I minus minus. So we're now counting down as opposed to counting up. And we want to glue that letter plus equals str.substring I plus 1. I'm going to glue the ith letter to our reverse string and then return it. So reverse 1 gave us Hamlet. If we were to reverse the same thing, let's reverse to Mushy. Okay, Mushi is now getting reversed. So this should be Isum. Yep, there's Mushi reversed. Okay, so Telma, Hamlet is reversed, and Isum is Mushi reversed. Okay, so those are our two methods for looping over the string. You kind of can compute the index on the fly, or you just make your for loop indexes, the I values actually be the indexes that you want. For loop I variable is the index that you're interested in. Okay, all right. So let's break down what those strategies are that I came up with in that last example, so that you guys have kind of some tools that you can employ when you're looking at a problem that you know you need a loop, and you're like, okay, how do I write this for loop so that I, accomplish what I'm trying to do? So what I would always start off with is, if you can't see the general behavior right away, pick a specific example. Now, make sure you don't code to that specific example. If I had gone back and I had put 4, so I wouldn't put, this isn't going to be 4 every time. It's always going to be the index of the last character. And likewise, this isn't always going to be A and then, I don't know, B and then C or whatever, right? You have to actually code to the general case when you code it. But when you're thinking about it, you can start off with a specific case, like Hamlet or Mushi or whatever, and then try to determine how many times you're going to need to do something. So if I'm like reversing a string, I know I need to look at every letter, right? So one letter at a time, starting at the front, starting at the back. There's actually faster algorithms for reversing a string. You actually could look at half the letters and grab 2 at a time, but so forth. Pick an algorithm and then decide how many times you need to repeat code. Refine it later. Just get it to work. Who cares? Especially when you're writing code on the AP test, there's 0 extra points for making it super efficient. If you just get the job done, that's all they care about. Okay, so first, determine how many times you think you need to repeat the code with a specific example. Write a list down. Actually run through the list. What are the indexes that you need to access? What are each of the indexes you're going to access on each time you repeat? Okay, so each time you repeat, are you accessing the first index and the second index and then the third? Are you accessing the last index and then the second to last and then the third to last, or what? So for your specific example, what indexes are you accessing? Try to determine a pattern. So what pattern is happening with these indexes? On that first example, first solution, the pattern was we started at the last index, the last character's index, and went down by 1 each time. So that was our pattern. It was 4 minus I. But then we had to say, okay, well, I can't always use 4 because it might be a string that's got 10 letters in it. So then you have to generalize it. So generalize at that point if you can generalize it, and if you can't, generalize your solution so that it works no matter how big the string is or how many times this loop is going to run. Pick another example and repeat, right? And then you might see, another pattern, right? Okay, well, how's this working now for, for this character or for this string that's got 10 letters in it, or this string that's got 5 letters or something, some different number of letters, and then you might be able to see, oh yeah, right, that's the string.length minus 4 or something like that, right? So so those are the steps for writing these kinds of loops. Start with a specific example, figure out how many times you need to loop. How many times do you need to loop? Once you've figured out how many times you need to loop, list out all those indexes that you're going to need to access for the string. See if there's a pattern. What's the pattern to those indexes? And if you can, at that stage, generalize to any string, not just the one that you're looking at. And if you can't, try another string and see if you can generalize from there. Okay, is at some point you have to generalize. You have to make that step of, okay, how do I make this work no matter what my string is? Okay, and that takes, you know, not used to it yet. We'll get used to this over time, but that's all about what programmers do, is generalize. Okay, let's look at another example. Let's look at this one where we swap adjacent letters. So we want to take this string foobar, for example, and we're going to swap the letters that are next to each other. So F and O get swapped, B and O get swapped, A and R get swapped, and so then that gives us OF, BO, RA, and then over here S and E get swapped, A and T get swapped, and then T and L get swapped. And then the E is not swapped, so then that gives us ES, TA, LT, and then the E isn't touched. It's a good idea when you've got things that happen to pairs that you figure out what happens when there's an even number of letters versus an odd number of letters, because things might behave a little bit differently and you have to think about those cases. In this case, we are performing swaps. How many times? How many swaps are we performing? That's a good way to think about this problem, because then that gives us a handle on our for loop, right? Our for loop is going to do something some specific number of times. For foobar, we performed 3 swaps, right? In a simple example, if I just had the word AT, then this is going to get swapped once to TA, right? So this is 1 swap. So we could, at this stage, figure out, okay, so how many times are we looping? We're going to be looping whatever half the length is. So if our length is 2, we're going to be looping half of that. Oops, 2 over 2. We're going to loop once. And if our length over here is 6, there's 6 letters, and we're going to divide that by 2, and that gets us 3, right? So that's one way of figuring out how our loop is going to run. So our for loop could do something like answer number 1. So our for loop could start at 0 and go string.length divided by 2 times. Now it might be useful here to try to figure out, is this going to work for odd length strings? Well, we had 3 swaps here. We had 3 swaps, and we've got 7 letters, and 7 divided by 2 is 3. So that in fact does work if we've got an odd number of letters too, because remember, Java throws away the decimal. 7 over 2 is 3. We want 3 swaps, so this is perfect. Okay, so we're starting at 0 and we're going up to string.length divided by 2. Okay, so the next step is to list out what the indexes are that we need to access. And so if we were to, let's make a pattern here. I is starting at 0, 1, and 2. We're looking at just foobar. That's what I is doing. 0, 1, 2. It's going up by 1s each time. And we need to access not just the F, but we want to access the F and then the O. So what's the F and then the O? Well, that's 0. So we have kind of like first letter and second letter. I'll put an F and an S there for the first letter and the second letter. So F is at position 0 and S is at position 1. Or excuse me, O is at position 1. So here's O. It's at 1. Okay. So 0 and 1 are F and O. On the next time our loop runs, we're going to look at 2 and 3. The next time our loop runs, we're going to look at 4 and 5. Okay, so now we are ready. We are primed to think about what the patterns are. So as I increases by 1 each time, F is increasing by 2, and S is also increasing by 2. S is just starting at 1 more at, I plus 1, right? Or yeah, it's 1 more than whatever F is, right? So how can we get these numbers from I? Well, we can get these numbers 0 from 0 by doubling it, 2 from 1 by doubling it, and 4 from 2 by doubling it. So our first letter, its position is at 2i and then 2i plus 1. 2i plus 1 is just the next index over. So the first letter is at 2 times I, because we want 0, 2, and then 4. And the second letter is at 2 times I plus 1, 2 times I plus 2. This is 2 times I plus 1 plus 1. So this is the 2 times I plus 1 over here, 1, 3, and then 5. And then this is 2 times I plus 2 because it's 1 more than that. And so then what do we need to do? Well, we're grabbing the second letter and putting it in front of the first letter. So we're going to glue them in that order. We're going to glue second letter and then first letter so that we go OF and then glue that to swapped. And that's our whole loop. So to break this down again, we decided we needed to loop 3 times for foo bar, and we wanted to loop 2 times or once for at, and so that's the length of the string divided by 2. Then we made a list out of all the indexes that we needed to access for each loop run. So we listed out all the indexes for I as we went. It was 0, 1, and then 2. And then we listed out what F indexes we wanted for the first letter and what the second letter indexes were. So we were 0, 2, and then 4, and then 1, 3, and then 5. At that stage, we determined a pattern that F was double what I was, and S was double that plus 1. So there's double what I is, and this one is double that plus 1. And then we just, once we had those letters, we glued them in the opposite order, second and then first, and that swapped the adjacent letters. So let's code that up. I'm going to go ahead and actually pause the video here and come back to finish this lecture tomorrow. This should be plenty actually for you guys. It's already a 30-minute video. So you can go ahead and code this up if you want to. And we'll look at another way to solve this problem in the next video, okay? Alrighty. You guys have a good rest of your weekend, and I'll see you on Monday.